Hello everyone. Today we are going to do finite element analysis of composites. So we have a 4-layer graphite epoxy composite laminate. So we have a composite laminate subjected to an axial load where the principal stresses in the respective plies will be analyzed. So this is a 4-layer graphite epoxy composite laminate with orientations 0, 90, 90 and 0. So a finite element model will be constructed using Hypermesh where the principal stresses in the respective plies will be analyzed. So the properties of the ply will be as follows. And the loading conditions is also shown in this figure. So these are the values which we are going to use in the software. And remember that we are going to follow SI unit system. So once you open Hypermesh, go to Preferences. In Preferences, click on User Profile. Once you click User Profile, you can choose OptiStruct. So the user profile will be chosen as OptiStruct. So once you are done, we'll start our analysis. So this is a model browser, and make sure that this browser is the active one. And this area will be the graphics area. And this area is model browser. And this, what you see, file, edit, view, collectors, geometry, mesh, and all these are considered under menu bar. So now let's proceed by creating a material. So in order to create material, you can go to these materials and click create. An alternative way of doing this is by clicking this icon. By clicking this icon, you can now enter the name, which will be graphite epoxy. Type in graphite epoxy and now choose a suitable color. Now the card image must be selected to Mat 8. So click on this card image and choose Mat 8 and now click. Now click on create or edit. Once you click on create or edit, now here is what you have to enter the values. These values you have to enter in this box. So E1, the value of E1 will be 155.0 e power 9. Press enter. And the value of E2 will be 12.10 e power 9. E9. New 12 will be 0.248. Enter. G12 will be 4.4 e power 9. G1Z will be also be 4.4 e power 9. G23 or G2Z will be 3.2 e power 9. Enter. Once you finish entering the values, click on this return and click return again. Now if you click these materials, if you go to models tab and if you click this material, you can see the graphite epoxy has been created, and in order to verify its properties, you can just scroll down here. Once you have finished clicking the materials, now we have to create a property. In order to create a property, go to this properties, click create and click properties. An alternative way of doing this is by clicking this button, properties. Now here enter graphite epoxy prop. This will be the name of the property. Now card image, you have to select pcomp. In order to select pcomp, click on this card image and search for pcomp, PCOMPP. There is double P at the end. Now click on this. Once you are done, click create. Once you click create, you can see your property has been created here. Now here click return and click on this property, click on this square box and choose a suitable color. Once you are done, you can verify the properties, verify the settings in this. Now we have to create the component. In order to create a component, click on collectors, create components. An alternative way of doing this is by clicking on this icon, component. Now in here, in this component name, type in the name plate, P-L-A-T-E, and now choose a suitable color. In the property tab, click on this property button. Once you click, choose the graphite epoxy property which we have defined previously. Once you have chosen, you can click. Once you have chosen, click create or edit. Once you are done, you can see here the plate property has been created. Now press the return button. Now under this component, you can see this plate, and here you can see the material has not been defined for this. Now click on this and now choose graphite epoxy and press OK. Now you can see for this plate the material has been defined as graphite epoxy and the property has been defined as graphite epoxy property graphite epoxy prop. So our component has been created. Now our component will be a surface. Before creating surface, we have to create lines, and before creating lines, we have to create nodes. So click on this geometry tab and click on these nodes. Once you click on nodes, click on first option, which will be x, y, z. So we are creating nodes using coordinates of x, y, and z. So our first point will be at the origin, which will be 0, 0, 0. Here 0, 0, 0 represents x, y, and z respectively. Now click on create. Now you can see here the node has been created, but it is not visible. So press F on the keyboard and the node will be at the center of the screen now. Now the second point will be 1, 0, 0. So x will be 1 and y and z will be 0 and 0 respectively. Now click on create. Now the second point has been created as shown in the figure. Now the third point will be 1, 1 and 0. So after you enter the values, click on create. Again the third point will be 0, 1, 0. Click create. So now the 4 nodes has been created. So now if you would like to display the number of the nodes or the node number, for that you have to go to geometry, check nodes and numbers. So go to geometry, check nodes, numbers, and here click on nodes and choose all. So here we have only 4 nodes, so I have chosen the option all. Once you are done with that, check this box for display and press this button on. Now you can see that each of these nodes has been numbered 1, 2, 3 and 4. Now to fit these 4 nodes onto the screen, click on this X, Y. Once you click this, you can see the nodes have been fit into the screen. Now click return. Click return again. Now we have to create lines. For that, go to this geometry, click on lines. Now click on this second option, which will be linear nodes. Once you click, you have to choose the option of node list. Click on node list, that's it. Now click on the first node, on the second node. Now these 2 nodes has been selected and now you click create. Again you can click second node and the third node. You can see it has become white color, so that means it has been selected. Now click create. Now click third node and click fourth instead of fourth. By accidentally, if you click any other node, you can cancel it at any time by clicking this button. So now this has been deselected. So again click third and fourth, create. Again fourth and first and create. Now you can see 4 lines has been created. Now we have to create a surface using these 4 lines. For that, first press return. Now in the geometry tab you can see surfaces. In the surface tab, go to this spline or filler. Once you come to this tab, make sure that this auto create free edges only is unchecked. Now keep tangency must also be unchecked. Now click on first line, second line, third line, fourth line. So all the 4 lines has been selected. Now click on create. Now the surface has been created. In order to visualize the surface, click on this button. Here choose the option shaded geometry and surface edges. Once you choose this option, the surface is visible to you now. In order to verify whether it is really a surface, click on the left control button and hold your mouse left button and try to drag it over the screen. Now you can see this is a surface. At any point of time, to zoom in and zoom out, hold the control and use the mouse wheel down and up to zoom in and out. Once you are done, click this XY button to fit it onto the screen. Now click return. Now you can see that the plate has been given a yellow color. That is because we have chosen the component color to be yellow. Now we are going to mesh this model. Before meshing the model, we are going to clear any temporary nodes. For that, press Shift F2. Once again, press Shift F2. In here, choose the button Clear All. So it is going to clear all the temporary nodes. So the temporary nodes are these 1, 2, 3 and 4, which we do not require while meshing. So clear all, and you can see those 4 nodes from the corner has been cleared off. Now click return. Now we have to set some meshing options before we start meshing. For that, go to this preferences here and then click meshing options. Once you click this, you have to change some settings before you start your analysis. So first, in the node tolerance, keep it as 0.01. So the node tolerance will be 0.01 and the element size will be 0.05. Once you are done with it, click return. Now in order to mesh it, and this is a surface, so we are going to do a 2-dimensional meshing. So click on 2D tab over here, and here you can choose the auto mesh. Let me press return and let me show an alternative way of doing this. Let me show the quick shortcut, which is F12. So press F12 to get this menu. In this, select this surface and make sure that this option elements and surface, here this surface option is highlighted. And the element size must be set to 0.05. Here in the mesh type you can see that it is set to mixed, but we don't need mixed, we need quartz. So choose quartz as the mesh type and the element size is 0.05. Now the surface is already chosen. And elements to current component. Make sure that this option is element to surface component and not element to surface component. It should be elements to surface component, and this is first order and keep connectivity. And make sure that this mapping, the size is unchecked and the skew is unchecked. Make sure the size and skew are unchecked. Now click create mesh. Now you can see the mesh has been created on the surface. Now you can see in the status bar over here 400 elements were created. You can do a simple max and you can find out how many elements are created. Because this is a regular mesh, it's easy to do a simple mathematics to understand that 400 elements were created. Now in order to see the mesh, in order to see just the mesh, you can also use the wireframe mode. So click here and choose the wireframe elements skin only. Okay, now click on this button, which is wireframe geometry. Okay, sorry, first I have to press return. Once you press return, okay, that option is visible here. So by clicking this option, yes, it becomes wireframe. Now you can click this option to see only the elements. So if you click this option, it also shows the component as well, the surface as well. So in order to disable the surface from the view, you can click this button under components. If you click this button, this will disable the mesh from the view. So from this graphics, the mesh will become visible and invisible by pressing this button. If you press this button, the surface will become visible or invisible. So let's keep only the mesh on, and let's keep the surface invisible. Now we have to set the material orientation for the elements to match the system XYZ orientation. So click on return. Now once again we have to set the material orientation for the elements to match the system XYZ orientation. For that, click on this 1D tab. Once you click the 1D tab, click on systems, which you can see here at the bottom. Once you click here, you can choose the material orientation, which is also at the bottom. Now click on elements here and click on all. Since all the elements, we have to check the orientation for all the elements, so we will choose the option all. Now material orientational method we'll choose here by system axis. So make sure that material orientation method is by system axis, and the size here should be 0.5. Enter. And make sure that this option is local 1 axis. So local 1 axis. Now click on this system button, and once you click here, you can see that you have to use your mouse to click on this global coordinate system. So once you choose this axis, you can see that it has been selected, so it has turned white color. So once you are done with selecting the axis, click on project. The material orientation of the selected elements will now be based on the selected system. Now you can select the elements and you can review. There will be arrows pointing in the global X direction for the elements. In order to visualize it, because of this color it is not easily visible, so let me change the color to pink. Let me change the color to dark blue. Now let me select in order to select multiple elements, hold shift and just drag. Now all the elements are selected. Now click on review. Now in order to zoom in, left control button and use the mouse scrolling. Now you can see that all the elements are in one direction. Now you can click this wireframe mode, and you can see the arrow marks are pointing towards one direction. All the elements are having one orientation. Now press return. Now we have to create plies. In order to create plies, you can go to properties, create and plies. An alternative way of doing this is by right clicking in the model browser, create ply. You can see here create ply. Once you click here, create ply window comes up. Now in the name, type ply1. The card image should be ply, and the color, let's leave the color for now and we'll worry about it later. Now the material should be chosen as orthotropic material, and the material should be graphite epoxy. Now the thickness should be 0.000 0150. Press enter. Now for the orientation should be 0 degree for the first ply as shown here. So we are having a 0, 90, 90, 0. So the first ply will have 0 orientation. So that is why we are giving orientation of 0. And this 0.000150 in meters, that means it is equal to 0.150 mm. And make sure that in shape we are chosen that element and not set line or surface. The shape should be set to element. Now click on elements and now click on these elements again and choose all the elements. And now click on proceed. Now we have chosen all the elements for the first ply. Now make sure that this output results is checked. Make sure that this card edit ply is unchecked. And make sure this close dialog box this is also unchecked. Now click create. Once you click create, this you can see in the model tree ply 1 is created. Now let's create ply 2. For this ply 2 the name will be ply 2, card image will be ply, material type will be orthotropic, all the things are same. Material is graphite epoxy, thickness is the same. Now but except the orientation will be 90. Press enter. And now elements, click on elements, choose all the elements. Now proceed. Now click create. So you can see the ply 2 has been created. Similarly go for ply 3, everything is same, orientation is also 90 degree. Now go to elements, choose all the elements. Now proceed. Now click create. Now for the ply 4 the orientation should be 0 degrees, rest all are same. Now click on elements again, or proceed and click create. So now you can see 4 plies has been created. Now let me cancel. So let me choose ply 1, control hold and choose ply 2, ply 3 and ply 4. Now click on one of these and now click on auto color. So now you can see that each of these plies has been auto colored, and so that the colors are not matching. Now let me turn this on. Let me turn back this on. Now the ply 1, 2, 3, 4 has been created with orientations of 0, 90, 90 and 0. Now we have to create a laminate. In order to create a laminate, go to properties, create and laminates. An alternative way of doing this is by right clicking in the model tree, create laminate here. So create laminate. So now the laminate is created. So for this we are going to name graphite epoxy. So name of the laminate will be graphite epoxy and the card image should be selected stack. Now the colors, choose a suitable color, dark blue. Now the laminate option should be selected as total. Now here under the name just click and you will get this option. So choose ply 1. Now next you can choose ply 2, next choose ply 3 and next choose ply 4. Okay, sorry, I have to choose ply 4. Yes. Now card edit laminate upon creation should be unchecked and this close dialog upon creation should be checked. Now click create. So now if you scroll down you can see here laminate. A laminate called graphite epoxy has been created. Now we have to create a load collector. In order to create a load collector, we can go to collectors and create and load collectors. An alternative way of doing this is by clicking this button, load collector. So now the load collector will be created. So the name should be SPC. Now the card image should be none. Now for color, let me choose red. Now click create. So the load collector has been created. Now press return. Now we have to apply constraints on our model. So for that, go to boundary conditions, create and constraints. Or an alternative way of doing this is going to analysis tab, click on constraints here. Now create. Now in here we are going to fix the left edge. So in order to select the edge, we can use your left shift, hold and drag. Now you can see all these nodes has been selected. Now we are going to fix all these nodes. So these options degree of freedom 1, 2, 3, 4, 5, 6 should remain checked. It should remain checked. Now click on create. So now you can see these nodes has been constrained from 1 to 6 degree of freedoms. Now use the shift button again and select all these nodes which are below and all the nodes above. Now here we need only 2, 4 and 6. So make sure that only degree of freedom 2, degree of freedom 4 and degree of freedom 6 are checked. Make sure that all these nodes at the bottom and all the nodes at the top are selected. Now click create. So you can see, if you zoom in, you will be able to see that the nodes on the left edge are constrained from degree of freedom 1 to 6, whereas the nodes at the bottom and at the top are constrained only for 2, 4 and 6. Now click return. So now this body is being constrained. Now we have to create displacement constraints at the right edge of the plate. For that, again go to this analysis tab, go to constraints. Now we have to give, as per the problem, we have to give the loading conditions epsilon x as the value shown here. So for this type, check degree of freedom 1 and enter value of 0.001. Enter. Yes, degree of freedom 1 should be set to 0.001 and rest leave as it is. Now using shift button, choose all the nodes as shown here. So hold shift and drag your left mouse button to select all these nodes. In order to zoom in, hold Control and hold Control and move up and down the mouse buttons. After choosing, click create. Now click return. Now we have to create load steps. In order to create load steps, go to setup, create load steps. An alternative way of doing this is clicking on analysis tab, going to load steps. Now we will name it as linear static, since this is a linear static analysis. Now check this box SPC and click on this button and choose SPC. This SPC which you have chosen here is the same as this SPC which we created right now. Now click on return. Now in order to visualize the plies, go to this option, click on this 2D detailed element representation. Now in order to hide these constraints, click on this button and these constraints will be hidden. So again, you can click it to turn it back on and click it to turn it off. And now click on this button, layers, composite layers with fiber direction. So just click here, composite layers with fiber direction. So if you click XY, you can see the direction in which it is being pointed. But for now, we have to visualize the thickness. Now go to preference and select graphics. Once you click graphics, you can see in this option, in this ply visualization thickness factor, instead of 1, type 100. So what it does is that it will cause each ply in the graphics area to be displayed with a thickness of 100 times the actual thickness. Since the thickness is very small, we are not able to visualize it. By entering the value of 100, it has been multiplied with 100. So now you can see there are 4 plays, 1, 2, 3 and 4. So you can do this, you can see this by pressing this button XZ. Now you can click return. Now return again. Now we have to give a global output request. For that go to Analysis tab, click on Control Cards. In Control Cards, click on this Next button. In here, you have to click on Global Output Request. Here, go down till you find C strain and C stress. So you can see C strain and C stress has been selected. Now in this type, click all, and again in type, click all. In the option, it should be set to all, and the option 1 should be set to yes. Now click return. Now we have to launch the OptiStruct job. For that, go to Analysis tab again and click on OptiStruct. So far we have not saved it, so let's save it first. So go to File menu, click Save As, click Session. Now let me save it in desktop with a new folder. Now the session has been saved. Now similarly click on Save and save the model.